We're stepping back a little in time today to answer a subscriber question. Number 1, PCI Express 3.0. Number 2, Bifurcation. And number 3, the X299 chipset high-end desktop. 2017-2019 is our time frame. We're looking at a purpose-built computer, a DAW, a digital audio workstation. And the subscriber has asked the question, and this is about installing a quad card in his machine. And for those that are wondering about the black tape, that was for an emissivity reading. But anyway, he's got an ASUS motherboard and with the X299 chipset, and when we get to the comment, we'll read that question, and then we'll have our title for the video. And my suggestion is going to be, if you've got an ASUS motherboard, go ahead and install an ASUS quad card, the Hyper M.2 x16 Generation 4 card. Whether you need the Generation 4 or not, I would look at the Generation 3 and the Generation 4, see which one's the better price, backwards compatible. Same goes for the M.2 NVMe drives that are going to go on this card. Whether you get PCI Express 3 or PCI Express 4 drives, you will only achieve the speed of the chipset X299, which is PCI Express 3. We'll get more into that in a bit. But if the other drives for PCI Express 4 are a better price, a better deal for the money, then by all means get those. Now to reiterate, understanding the specs that I outlined in the beginning, we need to understand the problem and the solution as we look at how this is going to work. Because our goal is to keep it simple and make it work. We'll read the conversation in the video comments to organize the steps required to implement this strategy. Now we have a lot of information. We want to keep this tight that we're going to need to organize before we can get started. Now to reiterate, we're going to be looking at PCI Express resource allocations. Number 1, we need to look at the motherboard, brand, model, and revision. Number 2, we need to look at the CPU because it matters according to lanes based on the processor for the chipset to install a quad card and to bifurcate. And number 3, we want to verify according to the chipset. To the comment and the title of the video of the motherboard in question, details matter. Now this question was asked on our video about the ASUS ProArt Z490 Creator 10G Thunderbolt 3 motherboard and the x16 M.2 NVMe quad card. And the comment is from Ehab Mohammed. Thank you for answering our question. Please answer my question. I'm a composer and a singer. I use Contact with Cubase and recording our band music, also DaVinci for edit some videos. I have 2 M.2 NVMe Samsung 970 EVO 2 TB as my main C drive. It has the system and Windows files plus another 970 EVO 2 TB as a second drive D, and 1 extra Samsung 960 Pro 1 TB for the third drive F, and they are all installed on the motherboard, as this motherboard allows me to install all 3 together. That means I lose, well, to help in the comprehension of this, what that means is that you use, not lose, but that you use 4, 4, 4 for each M.2. That's 4 PCI Express lanes. Okay. I tried before I installed the Windows OS in the BIOS to make the 3 NVMe as RAID 0, but I couldn't undo it. Note the important thing to me, I want to buy any RAID controller, and we'll specify that. High Point ASUS ASRock to put 4 NVMe M.2 4 TB total for 16 TB. I want to make that the main desk C drive. And if I can also make the other 3 M.2 onboard the motherboard as BIOS RAID 0 backup drive D. I don't know how and what the best solution from your experience. To me, I think most people, they want to take advantage of all the possibilities available and expand storage in all the ways available to them. I absolutely agree. I don't want to lose the speed of the NVMe, so what better, in my case, which model, and for my 3 NVMe are installed already, should I remove or keep it? My CPU. Now this is important. We'll get into the specs and title of the video. My CPU is 48 lanes. The motherboard, title of the video, is going to be the ASUS ROG Strix X299E Gaming. And if you notice here at the end, 2. I want to thank this subscriber for editing his message. And when I originally read this, he had on there the gaming. Then he came back and edited it and had the gaming 2. That difference matters. It's a difference in 2017 and 2019. I'm going to get to it. Because whenever we're looking at how you're going to add one of these quad cards, it's always about resource allocation, but it's specific to a specific motherboard brand, model, and revision. And because we've got ASUS we're working with, that helps simplify things in a lot of ways. But again, change one thing changes everything, and the specificity matters. Operating system in Windows 11 Pro and the Intel i9 10940X 48 lanes. As long as we're above 44 lanes, we're good to go. and he's got an EVGA RTX 2070 Super Ultra FTW3. I don't have any PCI Express devices except the GPU. Sorry for my long story. I appreciate what you do. Thank you, sir. Well, we very much appreciate the question, and the answer we're going to have to this is going to be a lot of information, because there's a lot of things in play that we need to look at and verify so we can decide then what the best plan of attack is, because our goal is going to be to keep it simple and to make it work. We have more. And the first reply. Hi Ehab Muhammad, welcome. I'm answering questions just as fast as I can. And I got to interject right now, this one took a little bit of research, because going back in time since I lost a hard drive, I didn't realize I had so much data on it, because there's some things that I know, but knowing what I know and giving you the documentation are kind of two different things. Some of the documentation I had to dig for, and it's like, you know, I know what I'm looking for, but to tell you what it is, a lot of people have had trouble with some of these steps. I don't know why, but it's like anything. Once you've done it, it's easy. It's doing it again. And I kind of feel like McDonald's about, 1 billion served. We've had videos on this quad card of these types, of all of them. That's one of them's got over 100,000 views. So a lot of people are very interested in this, and I understand where he's coming from. This is what we talk about, why it's so important to understand when you buy a computer, you want to be able to upgrade that computer. All computers have a limited availability of an upgrade path. At some point it cuts off. Some sooner than others, won't get into that. But for this, for the path you want to go down, this will work, and I'm going to show you how. First, we got to get through all the comments. Okay, your question is going to require a video response, and that's what we're doing. To reiterate, you have the ASUS ROG Strix X299E Gaming 2. Got it. This is a bit involved, and to reiterate, will require a detailed analysis. And this will make a great video if you don't mind the wait. This is what we're doing. And the response from Ehab Muhammad. Of course, sir, I am one of your followers. Appreciate that. Thank you. I am waiting for you, and I expect it will be a video that will bring great benefit to me and to many people. Thanks. Well, that's the plan. Okay, first thing we need to do, let's take a look at the motherboard. Now this are the tech specs. I'm going to take a quick gander right quick. I'm verifying X series processor, X299 chipset. I know the DIMM's 128 gigs. Here we are on the processors. And this is important. X series processors. That'll come up again in a minute. We need to look at the expansion slots. And this says we have 3 PCI Express 3.0 by 16 slots. And this says we have by 16 by 8, a 16-lane CPU and a 44-lane CPU. We'll verify that information once we get into the manual, because there's some obfuscation going on again. And storage. This is why the details matter. This says one M.2 and a second M.2. Let's go back, look up here at the motherboard title. This is the gaming motherboard. So there's a difference right up here at the top. Take a look at that. The Gaming 2. And that's the board we're going to be working with. Not the original, but the second one. We get asked every once in a while about motherboards, why they do revisions. Well, this is one of the more obvious and the easiest to understand, but usually, historically, typically, motherboard revisions occur because traces on the board cross something like audio, where you'll get a zipper noise, and that's usually what they're addressing. Sometimes it could be some of the capacitors. Sometimes it might be something with some of the logic. Could be the chipset. We've had chipsets change for no reason at all. But this is one of the most obvious, where we're going to get into bifurcation, where we're going to reallocate resources. However, the difference in the version 1 and the version 2 motherboard is there's a physical differentiation in those resource allocations. Fascinating stuff. I like the revision 2 motherboard better than the first version. It's going to become apparent. I'll show you the difference just real quick, because details matter. So here we'll take a look at our tech specs. X series processor, X299 chipset. This will take 256 gigs of RAM, whereas the first one could only take 128 gigs. That just shows how technology's changed. And a little more information about the processor. We have to have an X series processor. Remember, the first motherboard was 2017. This motherboard was about 2019. That's what's important to know. And here's a reallocation of resources that's a good example. 3 PCI Express with 16 slots by 16 by 16, 1, 2, or 3. We get 2 16-lane slots and 1 8-lane slot. And this says we get a 16-lane slot a 16-lane slot or a 4-lane slot? Curious. So we're going to want to look at BIOS bifurcation and see what they've got going on. And this also gives the option of by 16, by 8, and by 4 electrically. One PCI Express 3.0 by 1 slot, which is 1 lane, and a 48 lane. So as long as we're 44 lanes or better, we're in good shape to do what we need to do. We'll verify in the manual. And now here we are at storage. 2 M.2 sockets and a third M.2 socket. Okay, and also supports Intel VROC, which is a virtual RAID on CPU, or virtual RAID on chip, X series, and support for RAID 0, 1.5, and 1.0. And 8 SATA ports, which is 1 PCI Express lane per SATA port. So what we have is a reallocation of resources physically to give us better slot assignments, where we have 2 16-lane slots and an 8-lane slot. And to reiterate, we have 3 M.2 drives as opposed to 2 M.2 drives. My expectation on that, we'll see how it plays out. The first 2 will probably be to the CPU, and the third one will probably be through the chipset, but we'll verify that. Let's go to the manual. And the manual is kind of an interesting thing, because we're going to go to the manual, and we're going to be drifting in and out of this support area more than once. First of all, the manual. We see a user's manual, and we see a BIOS manual. But there's another manual we need that's not here that is from ASUS that we're going to have to pull up that I'll have a link for. The user's manual has most everything we need, but not all of everything we need. The BIOS manual in here is kind of a misnomer. Some of the information that should be there is not there. So this manual for the BIOS is not as, how do I say this? It's kind of POS. It's a nice way to put it. Okay, we'll download the manual for the motherboard, and we're going to do a search for specification. And under specification, we do not have a diagram, but we have specification summary, we have motherboard layout, and we might need to look at expansion slots. So we'll start with the specification summary. That takes us to page 9, and from the top down, let's verify. Intel X series processor, supports VROC, virtual RAID on chip, X299 chipset, 8 DIMMs, 256 gigs, quad channel architecture, XMP profile, hyper DIMM support. Okay, and here we are, the details. The 48 lane CPU, that's extremely important. 3 PCI Express 3.0 by 16 slots mechanically. Electrically, by 16 by 16 and by 8. So we'll have one for the GPU. The second one is where we're going to put the quad card. And then we have a third slot by 8 mode. And if we go on down through the chipset, we have PCI Express 3.0 by 4 electrically and PCI Express 3.0 by 1. And if you'll notice here, we've got an asterisk, so we've got PCI Express by 1 slot shares bandwidth with USB front panel connector. More than likely, I'll think you probably want to use that front panel USB connector than you will that slot based on what you're doing. Okay, a little bit about the VROC. We're looking at storage. So this is on page 10. 2 M.2 to the CPU that mentions VROC. We won't have to use VROC, but we need to point this out. I'll do a little bit about VROC, but I don't want to make the whole video about VROC because we don't need it. Here's the second. Intel X299 chipset supports Intel RST, and RST is what we're going to use. So you have both of these technologies. You can use one or the other. Now this says with the IRST, Intel Rapid Storage Technology, 1 M.2 underscore 1, and then M.2 underscore 2 and M.2 underscore 3 are supported by a 48 lane CPU and a 44 lane CPU. Okay, needed to verify that, good to go, so we're set. So we have the option of either one. We're going to use the second one, RST. But I'll mention the VROC again in a little bit about the chips, because the question has come up on different occasions, and if somebody asks in this, that's the only reason I want to put it. Okay, there's 3 VROC chips. Only 2 are relevant to this build. Only 1 is relevant to this installation if he were to use it. And I'll get more into that when we talk about VROC, but just I'm aware of those 3 chips. It took me a while. In fact, it took me quite a while. I knew about 2, but I couldn't remember what the third one was. When I figured out what the third one was, then the information became available to show me what I was looking for. Used to, you could go to Newegg and find this stuff. It's extremely difficult now at Newegg, unless you know what you're looking for, how to find it. Back to what we're working on. We still have a lot of information in play that we need to verify. You've got Wi-Fi. My suggestion, because you're using this for a DAW, that's the first thing you want to turn off because of DPC latency. If you can remove the chip, remove it. If it's too much of a hindrance to do so because the system's already built, then all you need to do is just turn it off. Now I want to take a look. I've gone back to the index, which is on page 3, And let's look at the motherboard layout. I like to verify. DIMM slots, 4 on each side of the CPU. PCI Express by 16_1, _2, and _3. So we have, to reiterate, 2 16-lane slots and one which is an 8-lane slot. And if we looked at the, again to reiterate, the previous version of this motherboard, which I won't take the time to do, we would see a different physical allocation of these resources. That's why this matters. And we can see M.2_2. So where's M.2_1? And I see M.2_3. Here it is up here on the right. M.2_1 is in a socket, so it sticks up. It should have good clearance for dissipation of heat, and should be easy to put a heat sink on it. So M.2_1, and then of course M.2_2, and then M.2_3. And to reiterate, M.2_3 is through the chipset. So I'm going to have a recommendation on my suggestion. Take it with a grain of salt, because even though I make a suggestion, I'm going to tell you how to do what you want to do. So the first thing we've got, well, before I get into this, what I want to do is let's go take a look at the CPU right quick. And your processor is the X Series i9 10940X 2019. You've got 14 cores, 28 threads. That's what I wanted to see. And the processor supports 256 gigs of RAM and PCI Express 3.0, 48 lanes. Okay, just a quick verification. Now let's go check the chipset. We always find chipsets fascinating, especially when you look at the design versus the implementation, because a lot of this stuff looks great on paper, but once manufacturers get hold of it and start monkeying with it and decide this goes here and that goes there, this is a good example of the revision 1 versus the revision 2 that we're looking at. Again, to reiterate, I like the way this revision 2 board is laid out, but I like to verify based on the specs what's what. That's what we're doing, because this never gets old. Okay, the X299, or to reiterate, 2017, and we're looking at a 2017 chipset with a 2019 motherboard and BIOS updates. 2 DIMMs per channel, quad channel, and we are again PCI Express 3.0, and the configurations can be by 1, by 2, or by 4, and the maximum number of PCI Express lanes are 24. Okay, we've got that sorted out. Let's go back to the motherboard. Okay, we have verified the motherboard and we understand the layout. There's a document I want to share with you for what I'm going to suggest. To install the quad card, let's deal with the hardware side, then we'll deal with the software side, and in between that, I'm going to talk a little bit about VROC. Okay, you want to install this quad card in your machine. No sweat, piece of cake. My suggestion is going to be for the hardware, the 3 drives you've got, because you're going to redo the machine, so it's no big deal. I would take the 3 drives that you have and put tape on them, whether it's a Post-it note or some blue painter's tape like we use when we're labeling stuff, and label each one of those drives what they are. Now, those can become the backups, or if you reformat them. I know how long it takes to install virtual instruments like Contact. A lot of time it's excruciating. But take those 3 drives off, install the quad card. Now, which one? You have an ASUS motherboard, get an ASUS quad card, just like this one. If you go with something like you mentioned about the High Point, well, remember we talked about number 2 in the beginning, bifurcation. Okay, there's 2 types of bifurcation. There's a kind of bifurcation that you do on the motherboard, which your motherboard can do, and then there's the kind of bifurcation that is done on a card. Those kind is a High Point card. Because they have a PLX chip, they self-bifurcate. It's probably a Broadcom chip, but it's like buying another motherboard. Save your money and put that in the M.2 drive. So my suggestion, get an ASUS quad card, which is the Hyper M.2 x16 card. Get your 4 drives. Now, whether you buy the PCI Express 4 version or the PCI Express 3 version, get whichever one suits you, whichever one you can find the best price on. To reiterate, backwards compatibility, same for the drives. If you want the most performance drives, based on speed, I would look at probably something like the PCI Express 4.0 3rd generation drives, because you're only going to get the speed you want out of your chipset, which is around 3,500 megabytes per second per drive. And when you put 4 drives in RAID, you're going to get better performance, but in RAID 0 will qualify that. You will not get the speed of 4 drives. You will get the speed of 3. So if those are 3,500 megabytes each, 3,500 times 3 is what you can expect. If you put in PCI Express 4.0 drives that are capable of 7,000 megabytes, because you have the governor of your chipset which says and dictates 3,500 megabytes, That's all you can expect is 3,500 megabytes per drive, which means even if they can run at 7,000 megabytes, when you put those 4 drives in RAID, you're only going to get the speed of 3. Not 7,000 times 3, 3,500 times 3. So look at the price. Let that be what dictates. And if you decide later to upgrade, if you get the PCI Express 4 version because it's less expensive, makes more sense. Okay, 2 ways to do RAID on this machine. As we have read, can be done with VROC. That's been, let's say that's been deprecated, so you don't have to. There are 3 chips. The first VROC chip was for, let me read this to you, and I'll have these links up. Now, this is a link that goes into Intel that talks about the difference between Intel RST and VROC. Why did we have, or excuse me, why did you guys that choose Intel have to deal with VROC? Okay, this is an enterprise solution that's trickled down to the desktop. So the first VROC chip was an enterprise chip. The second chip was for Intel only SSDs. Okay, we're not doing SSDs, we're doing M.2 NVMe PCI Express SSDs. So that's the one you want. There is the enterprise chip, which is also I think known as the premium chip. Then there's the ISS, I'll give you the part numbers. And then there's the standard chip, and the standard chip is the one that you would have used if you had done any other version of RAID except RAID 0. And we're only doing RAID 0, so we didn't need it even in the past, but now because of RST, no need for VROC. Now I could go more into that, and I'll have some links in the description for those of you who want to see it. For example, this one document that I wanted to share with you, what was the reason for it? This will tell you. VROC was about performance, and VROC that started as an enterprise solution was for professional workstations and server platforms. And even though the X299 chipset had 2 previous chipsets leading up to this, with the one previous to this chipset that I'm not going to mention, was considered high-end desktop, I personally don't consider high-end desktop until we hit X299 with Bifurcation. That was phenomenal. And a lot of stuff that we were going to do about Bifurcation on the X299 got superseded when we went to the AMD X399, then to the AMD TRX40, and now the AMD WRX80, which is on a workstation. So whatever's going to happen with the high-end desktop, this is fascinating to take a look back at this and make this work, which it will. But to reiterate, if you want to understand what the difference is in the two, it's in the links to the documentation I'll provide. Okay, all we need to do is RST for this, especially since you're only going to do RAID 0, which is what I call RAID with a seat of your pants, because RAID 0 is all about speed. And if anybody's curious about what chip is required, I'll have a link into Amazon that gives the pertinent information on which chip is which. Now, if I go look at the ASIN number on this, this will take me down to the part, because this is actually the standard mode. And the standard mode is for the NVMe. There's 3 models, standard, premium, and ISS. Now, Supermicro had a real nice description that I was able to find with some hunting and pecking about the VROC standard mode, the VROC premium mode, which you would not need, and to reiterate, the VROC ISS for Intel SSD mode. But you're not going to need any of them. If you did, that would be the one you would use. But I'll have a link for this if anybody wants to do some research. Okay, we've looked in the motherboard manual. We need to look in the BIOS manual. We're not going to find everything we need. To reiterate, most everything we need is going to be in the motherboard manual. However, we do need to take a look and verify some information in configuration, because things I can tell you generically on Intel are specific on AMD, and they're super easy to do. Laid out 1, 2, 3. However, doing this on Intel is a little bit more of a, well, specificity matters, a bit of a conundrum. But my point in telling you this is there's another document that you need that is not listed with the motherboard in the FAQ or the documents, and it deals with RAID. It's from ASUS. I'm going to share that with you too, and the link will be in the description. And this is the ASUS RAID configuration guide. So what we're going to do a search for is Intel. And you cannot just do a search for Intel RAID configuration guide. Because of the registered trademark, if that's not in there, it won't show up. Now there's a definition, there's talk about the serial storage devices. And this is the part that I find a bit frustrating, the way the information is listed. And I don't know whether to put it on Intel mostly, which I think is where it should be. But I think ASUS has some responsibility in how they have this listed. But they're just taking what they get from Intel and sharing it with us. So I'm trying to share with you on how to see how this works. Okay, the documents. The distinction being serial ATA versus PCI Express M.2 NVMe. And what we're looking for in the BIOS as we transition from hardware to BIOS, and the last part of this will be software, how to get this thing installed with the operating system. Now the first step talks about going to in the BIOS, which will actually be the unified EFI, and I'll give you the steps. But this talks about the PCH storage configuration. Okay, we're not going to the PCH storage configuration. We need to look at the CPU storage configuration because we're not dealing with SATA. And I'll flip back over to the manual because there's some discrepancy with these two. But this talks about the storage configuration, and if you're using a Hyper M.2 card, which you will, go to Advanced, and right there it is, CPU storage configuration, and set all the corresponding PCI Express slots that will have a card in it for the Hyper M.2 x16 or PCI Express by 4 SSD card. Okay, you want to set it for the Hyper M.2 x16, and that would be this quad card. And it has to be bifurcated because you're going to have 4 drives, and each drive requires 4 lanes, hence 4 by 4 by 4 by 4, 16 lanes. And it has to be fully bifurcated. And there's another document with ASUS that talks about these cards and all the different chipsets on how all that sorts out. I'll share that in the description as well. So that's another setting that you've got to make. And you got to turn off in the BIOS under boot CSM. That has to be disabled. Now, once CSM is disabled, reboot, come back into the BIOS, then you'll see a menu for under Advanced for the Intel IRST, Intel Rapid Storage Technology. And it talks to you about creating the RAID set and creating the RAID volume. Okay, I worked with the X299, but it's been some time ago. We're talking at least 3 years ago, could have been 5. But the specificity on this, I'll put in the description because I've had some people miss some of this. When you first, this is the way it works on AMD, and I expect it's the same on Intel. When you first install the card, you come up and you get ready to create your RAID, you're going to see, or you may see those 4 drives already there. Okay, if they are, you have to delete an array before you can create an array. So if you see 4 drives and you can't figure out how to get them together, you'll have to delete them out of the array and then create the array by putting it back in. That's what we have to do with the AMD RAID. And I expect probably the same thing with the Intel RAID, but I don't know that for a fact. But I want to point that out. So once you go through this and create your RAID array, set your stripe size according to the kind of files you're going to be using. And these are typical suggestions for normal size values. I won't get into that. We recommend a lower stripe size for server systems and a higher stripe size for multimedia computer systems used mainly for audio and video editing. So that's the read on that. Higher stripe size. You're going to be doing RAID 0. The suggestion is 128 kilobytes. And you can see here in the manual, it has suggestions for all the sizes that you can predefine. Now, you mentioned 16 terabytes for your capacity. You're going to have to allow some fudge because there's a little bit of how a drive is read. And this is about decimal versus binary, to reiterate. So when you're setting that up, you've got 4 drives, 4 times 4 is 16, 4 terabyte drives. So use the drives that best suit you. The only way to get over that decimal versus binary count is to use larger drives. And that's a lot of data. I think where you're at will be fine, but it's going to be under 16 terabytes because of that difference in the way they're counted. Think of it as marketing. Now the next thing we're going to look at in the manual, I'm going to go to page 5, and this should get us to RAID. Yeah, and we need to compare what's in the motherboard manual as opposed to the other manual. RAID configurations, RAID support, and we're doing RAID 0, definitions. And as you can see, the motherboard manual just doesn't give us a whole lot of information like we need. So going back to the RAID configuration guide, we'll go search for Intel, and we're looking for Intel Rapid Storage Technology in the Unified EFI BIOS. I need to interject, there's a menu that I've been looking for that I can't find that apparently Intel doesn't use, or else they use different terminology. On the AMD platform, there's a specific menu in the Unified EFI BIOS where you turn on NVMe RAID. I cannot find that in any of the documentation that deals with the Intel RAID on the ASUS board. So if there's something there about it, I'm not seeing it. So some of the stuff I'm telling you, I'm flying blind, but it's based on what I know about AMD. I can do that with my eyes shut. doing it with the Intel should be fairly simple, but you want to follow those steps. If you don't have that menu, to reiterate, to turn on NVMe RAID, once you set the quad card and once you've bifurcated the slot, turned off CSM, when you reboot, then you go into the RAID menu and you should be able to see the drives on that so you can set your NVMe RAID. Should be pretty simple and straightforward. Okay, to the best of my ability and to the best of my recollection, that should take care of the hardware, that should take care of the BIOS. Once you get through the BIOS, then we're going to talk about the operating system. You're going to install Windows. Okay, you're going to need to install Windows, and I'm going to talk about the Windows Media Creation tool. For those that want to do Rufus, different topic, different discussion, not part of this because I want to keep it simple. Okay, the requirements, probably easier if I take you to the link for the Windows Media Creation tool, and I'll have that link in the description. Now this link to download Windows, if you'll notice right here, says Update Now or Create Windows 10 Installation Media. You want to do that, download that tool. Now that tool that you're going to download, put it someplace where you can keep it and find it, because that little tool is going to then, once you download that, execute it, it'll then download the other information. Because there's two ways you can do this. You can download an ISO. If you want to write it to a CD, there have been reasons in the past that you might need it. Haven't heard anybody need it in a very long time, but there's reasons for it. So what you want to do is with the Windows Media Creation tool, I'm going to show you another link on this page where you're going to use a USB thumb drive. And the specifics on that thumb drive matter. And I've had a few people get caught up on this. I don't know why Microsoft doesn't put the details on there, but hey, you wouldn't need us if they told you. What they tell you is great. It's what they don't tell you is a problem. Okay, you're going to need a USB flash drive, 8 gigs. Okay, here's the kicker. You need a minimum of 8 gigs, but you can only use a maximum of 32 gigs. If you use a 64 gig disk with the Windows Media Creation tool, it will bomb. It'll go through this loop and it'll never install. So the parameters, 8 gig up to 32 gig. And then Windows will reformat the disk, run its magic, and put the stuff on there. That's the first step. Now, before you install that to execute to install Windows, you've got to have the driver that can see this. Because what you're doing, and this is a concept of Windows since Windows 95, for the operating system to see the drive, it's got to see the controller first. Native support is for the controller to be a controller. But when you change that controller to a RAID controller, you have to have a driver, and then that driver then will allow Windows to see the drive or drives that are on that controller. This, when it's set for RAID, but remember, these are I/O cards. These are not RAID in and of themselves. There are some definitions that talk about these as RAID. These are just I/O cards. So for those that want to install one of these and see 4 drives, easy. RAID is a second step, but it's not the primary function. There's 4 types of RAID. 3 is what we have historically talked about. There's a operating system RAID software. There's a hybrid BIOS RAID, which is what we're talking about now. And then the third is if you got an actual hardware card. Now the high point card falls in the classification where you want to talk about bifurcation. This requires motherboard bifurcation, the hybrid BIOS bootable RAID that you can do with this. You can also do with some of the high point cards a hybrid BIOS bootable RAID, because to reiterate, those have bifurcation built onto them, but they're the price of a motherboard. So those are all CPU-based RAID. Number 4 would be a GPU-based RAID, like G-RAID that we've talked about, which would be for a machine beyond this, but if you want the speed, you offload that processing power from CPU to GPU. But you got to have a third slot, which you do. You have an 8-lane slot, but to have that one 8-lane slot, which is a GPU, an NVIDIA GPU, just to run one of these cards, I don't think it's worth it. It's a possibility to do it on a TRX40, but I think it's more practical to do it either on a WRX80 or on a server, where you have, say, 2 or more of these cards. Then it makes sense. Okay, so now we're at the operating system. The driver that you're going to need, and this is something else that's kind of tricky. And this driver should be easy to find. Let's go back to the motherboard. Features, tech specs, gallery, where to buy, and support. So we'll go back to support. This time we're going to look at drivers and tools. I'm curious about BIOS, but for this it's not really necessary. but what we do need is drivers and tools. Okay, you're using Windows 11. Let me show you what happens if we pick Windows 11. We will never find the driver we are looking for. That driver ought to be under chipset. It's not. And I don't know whether to put this on Intel or ASUS. They're both responsible. Anyway, you're going to have to pick Windows 10, and then you will find, not under chipset, but under SATA right here, Virtual RAID on CPU driver. And we'll see all downloads and looking at RST, Intel Rapid Storage Technology driver. That's what you want. And it says AHCI RAID, which I think is extremely confusing because, yeah, you're not using VROC, you're not using SATA. AHCI deals with SATA. You're using NVMe, so that's the driver you want. Looking at the documentation that ASUS provides and how to do this, let me see if I can find it. Let's go to the RAID configuration guide from ASUS, and this little setting down here about creating a RAID driver disk. Creating a RAID driver disk for Windows. It's extremely helpful, and it says load the driver. And the disk you're going to create with a Windows Media Creation tool, you can take these files that you have to unzip and put them in a separate directory, drivers, whatever you want to call it, on that disk, so that then you don't have to have another thumb drive to go back and forth with. You just put the one thumb drive in, and when Windows gets to that point and says, what do I do? You point it to the driver, and then away it'll go. But knowing which driver you need, that's the conundrum. And I think this ought to be easier to find. Now this says and tells you what to do, but the driver I think you need is this one I'm showing right here. Yeah, now I'm hovering. If you'll notice right here, I'm hovering. But watch down here on the bottom, and I can't put this in both places, but when I hover over that, down here on the bottom left, it says driver DRV RST. That's what you want. You want to take that file, download it, unzip it, and what you unzip, you want to copy to a directory on that Windows Media Creation tool. And that then should allow you, as Windows installs, when it gets to that part that says, what do I do? You've got to load those three drivers that we talked about with RAID before. And I'll have the name of those so you can do that 1, 2, 3. So that should pretty well cover you to get to what you need. Okay, this gets the RAID card installed. This gets the operating system installed. That's the first part. The second part is you want those other three drives. Okay, this is all about keeping things simple. What I've just described is how to install the quad card, put 4 drives on it, and how to get the operating system on there and make it bootable with a hybrid BIOS bootable RAID. That's the first part. The second part, you want to take those other 3 drives that you have, whether you use them, keep them as backup, or get some new ones, and put those on the motherboard and put them together. Okay, those 3 drives. The first 2 drives are of equal speed. That third one, because it's through the chipset, is going to be a little bit slower. How much slower? You'll have to test. You'd have to test each one of them and see what you've got. But if you want to RAID those 3 together, that'll be fine. You won't get the speed of all 3 of those, but you'll get better speed than you would if you had 1 drive by itself. Okay, do this, these 4 drives, put these other 3 back on the motherboard, then RAID those 3 drives. You've got your secondary drive. Both are done from the hybrid BIOS for a bootable RAID. You've designated what's on this card because you've done the install for Windows to be the operating system that's on that, which is smart. And then the other 3 drives will be your second drive. So I hope this helps. I hope I didn't leave any steps out. I'm sure you're going to have some questions, but this needed a video to outline all this. And the key steps for getting this quad card in, keeping it simple, what you have to do with the BIOS, and then once you get ready to install Windows, and load those 3 drivers. We'll have a link up in case this might help on the Windows bootable NVMe RAID 0 tutorial on the Gigabyte TRX40 designator using Sabrent Rocket NVMe 4.0 drives. And in here we have highlighted the process on all the things that have to be done, the settings, what you have to control. That should pretty much cover everything. If I left something out, somebody let me know. I think that's everything complete. A lot of information, a lot of things in play. I hope you'll be able to get this installed to your satisfaction. And virtual instruments, I think, are the one thing that benefit from having a setup like that I have experience and knowledge about. Virtual machines also can benefit from that, like databases, but my experience is with the instrument. So hope this helps with your machine. My name is Gil Boyd. This is BuildOrBuy. Welcome. Thanks for watching. We look forward to seeing the next video. We're out.